So today we will discuss how to install an app on Linux. So I think a lot of you have already installed some app in Linux using yum, that is yum install python 3, or in Ubuntu apt-get install python 3. These are great methods, but what is so bad about this method is that to make this command work, you need sudo yum install python 3, and you are not guaranteed that you can get a root privilege on any of the machine, especially when you're working in a research facility. You will not be given a root account. Some package might be available by default. When the default isn't there, you might convince your department to help you to install it. You are work in a development field. You will keep updating your program, and you have to recompile the app, run it again. It's usually more convenient not to rely on others to install each version of the app for you. I will introduce two common build systems that are used to compile programs from source using operating system of your choice. We first start with Auto Tools. Let us try a simple demo software. Tar is a software for you to unzip files. We start by downloading the source. Let's get the newest version of Tar. So I have the tar latest source code file download here. The first thing is to unzip it. That is, of course, using the tar software, tar zxf tar latest.zip. That is for unzip extract. The file name is this one. We got a tar 1.32 here. Let us look at the files. We have a configure script, and then there are also some makefiles.in. These are not really relevant. You want to notice that you have a configure file here that is green. Green means it is an executable. You are going to execute this configure script, and then you get the makefile. In turn, you can use the makefile to install your program. As you can notice, there are source here. This source is the source code of the tar program, and there are also some test case. You can test your installation with these test scripts. Let's try. Usually, how to use this configure script is /configure. However, you will want some option. The first very obvious one is that if you don't have the sudo privilege, you cannot install it in the root. So you want a way to install it in your, for example, in your own home directory. The method is called prefix. Maybe home my directory builds. Enter. It will check your system for all the compatibility. Do you have the correct package? Do you have the compiler, the libraries? And also, what is your OS? Have you enabled some of the OS specific features? And then generate the correct compile script for you. After generating, you can see that you have a makefile here. To continue, just type make. This step will compile the program for you. To speed up the compile, you can also use make -j8. You are going to compile 8 files in parallel. Some makefile might support it, some might not. So whether it's effective depends on the makefile itself. But for most of the GNU tools, this j = 8 is always supported. Now you can see that the script has compiled some outputs here in the lib and also the source etc. file. You can see the program is still not in the directory that I specified. There's nothing here yet. After compiling the program, the next step you should be doing is to make check. That will check your executable, that it functions correctly. It will perform all the unit tests. A lot of time it's worth it, because if your program has some problem that you realize it later, it's better to fix it before you are using it. The last step is to type make install. It will install the program into the directory you have specified in the prefix. If you run it, tar version, it is the newest version. The default version of tar on my computer is 1.26, but I have downloaded 1.32, which is the newest. So this tar is the newest one. My default tar is an old one. There are additional help that you can get from the configure script is to type /configure -help. You can find a lot of options here, an explanation of prefix, installation directory. You can also change your library directory, your main directory, etc. here. And also some compilation options, such as enable some features or disable some features. Use a specific package as dependency. Use some other program of your choice to do the compression and decompression, etc. that are all relevant for the tar program. There are also additional environment variables that will influence your build. For example, CC will choose a different compiler. The default is GCC. My GCC is a very old version, GCC 4.8.5. Suppose you have another version of GCC which is newer, or even another version of C compiler that is not GCC, maybe Intel, maybe PGI. You could also use it by setting this CC equals to the path to that compiler. Moreover, you can set the C flag, LD flag to load specific library and set compiler flags specific to your compiler. We will discuss this compiler flags later. Another build system is CMake. I'll just illustrate CMake using the code we are going to try this year. It has a CMake based build system. It is easy to check whether it is using CMake. One thing you can see for a CMake build system is that it has a file called CMake list. We will start by cloning the repository. In this folder, we see the CMake list. It's a good habit to read the README first. It may contain some useful direction for you to compile your program. But anyway, we will start straight. We first need to create a directory for the build file. This directory is disposable. That means that if your build failed, you can just remove this directory and your build is gone. Let's make a directory called build. And to use CMake, we cd into this build directory and then CMake ... That is CMake, the parent directory. Yes, by the way, there is a difference of CMake 2 and CMake 3. They are not compatible. For CMake 3 compatible program, you have to use CMake 3. After you type CMake ... hopefully you will get a make file. You use the same way, make. Alright, so we meet the first error in our compilation process. It says, in the source code, this line, the for loop is only allowed in the C99 standard. That is, we need to use the option std equals to C99. We have to set the compiler flag. So we have to run the CMake again, define compiler flag for our C compiler. In CMake, we don't use environment variable. Instead, we use the C-like syntax -d for defining some macros. D CMake C flags for C compiler. CX flag is for the C++ compiler. Equals as the suggestion -std equals C99. Okay, and then ... Yes, CMake 3. Okay, we get the make file again. Make. Build successful. We have our program here. There are also other build systems outside, for example, Bazel, which is a Google build system. Mainly for myself is to install TensorFlow. Of course, you can pip install it now. For some reason, if you need to compile it from scratch for your own use case, you might need to use this Bazel. Let's try. Same thing. We git clone the code. It looks like it uses Bazel, but then it's also wrapped in a GNU Auto2 script. Oh, just try. Cannot find Bazel. Okay. Most likely, the build system should be supported by your administrator. You are not required to install the build tool yourself. So I will just skip the installation of Bazel for the moment. If there's no Bazel on your system, just install it or ask your system administrator to add support to it. So my Python location is this one, okay. Yes, the binary path is okay. Maybe just no for the moment. CUDA support is definitely important, but for demonstration, we just pick no. So after configure, you will be typing something like Bazel build this thing. And then it will check for dependency. For example, I don't have NumPy installed. You will need all the expect dependency. You have to install all this package. NumPy will Keras preprocessing and build again. So hopefully after some time it will work. Like my GCC is too old. TensorFlow is a hard thing to build, so maybe I'll just leave it here because I don't want to update the GCC.